Hey guys, it's Miss Van Tassel. So today we're going to look at how to graph exponential functions. And just to kind of recall from the last video, we're also going to just quickly look at how to set up and model our exponential function. So for this first example, it says Gordon, the financial analyst, is reviewing some accounts. He noticed that one account that started with $1,000 has grown 15% each year. How can Gordon create a function to model the data? So because it's growing each year by a specific rate based on the previous year, it's not growing at a steady rate or the same rate every single time. And so we know we're using an exponential function. And so just to kind of review, we have our function f of x equals our p, which is our principal or our starting amount. We're always going to put a 1 here to just represent the amount that's already there. And then this is a growth function, so we're going to add our rate, not subtract our rate. And it's growing at 15%. And so 15% we want to make sure that we're writing as a decimal, so that would be 0.15. And to the x value. And so let me fill in my p, or my principal, which was 1,000. Okay. All right, so there's my exponential function. Just gonna rewrite it here. Add my 1 and my 0.15. Okay. So what does that look like on a graph? And so I'm just gonna kind of carry this over to the next page so we can see it. Okay, so here's my exponential function, f of x equals 1,000 times 1.15 to the x power. I have a coordinate plane here. Now, normally we would graph both negative and positive values of x, but because this time we have a context to it, we're not going to graph all of those values. So in this specific scenario, x is my time. And I know that I'm not looking at negative time, so I'm really just going to be graphing in this first quadrant, since I'm starting with a positive value in my bank account and I'm only looking at moving forward in time. I'm going to be in this first quadrant. And so now I'm going to just set up my scale. So I'm going to put 1, 2, remember this is my time in years, 3, 4, 5, 6, I'll go up to 7 years. And then I know I'm starting with $1,000. So I want at least that much in my account. So I'm going to maybe go by, let's see, we'll go by 500s. Okay, so now my axes are set up, and so my next step is going to be to just make a table. And I'm just going to pick values for x, so 0, 1, 2, 3, 4, I'll go up to 5. I already know that he's starting off with $1,000, so if my time is 0, then I'll have $1,000 in my bank account. Another way that you could get that amount is by plugging 0 into the x value. We know that anything to the 0 power is 1, and 1 times 1,000 is 1,000. Now I'm going to use a calculator for the rest, so every time that I plug in, I'm going to do my exponent first and then multiply. So when I plug in 1, I'm going to do 1.15 to the first power, and then I'm going to take that answer and I'm going to multiply it to 1,000. I'm also going to make sure that I'm rounding to 2 decimal places every single time, since I'm dealing with money and we don't We don't use anything less than the hundredth place or a penny when we're dealing with money. So I'm just going to plug each of these into my calculator. So 1.15 raised to the first power, and then times 1,000, and I get 1150. And then I'm going to plug in a 2, so 1.15 squared, and then times 1,000, and I end up with 1322.50 or 0.5. And then I'm going to plug in a 3, so I'm just repeating the same process, 1.15 to the third power, and then multiply that to 1,000. And this one I do get 3 decimal places, so I'm going to round to 2 decimal places. So I get 1520.88. Then I'm going to raise to the 4th power, so 1.15 to the 4th power times 1,000. 1749.01. And then to the 5th power. 1.15 to the 5th power times 1,000, and I get 2011.36. Okay, so now that I have my table, I'm just going to plot my points. So 0, 1,000 is going to be right there. And then 1, 1150. So I'm really just estimating, so right about there. 2, 1322, that's going to be more in the middle. 3, 1520, so I'm going to be just above 1,500. 4, 1749, that's going to be more in the middle. 5, oh, this should actually be a little bit lower. 520, right about there. And so we do start to see this curve. It's going to continue to curve just like that. And so there's our graph. All right, so the next example, it says Gordon, the financial analyst, has been following 2 companies as potential investments. The table below shows the functions to represent the number of sales, f of t of 2 companies in t years. So here's company A, and then here's company B. Gordon is going to compare these companies in 3 different ways. He's going to compare them by initial sales, by growth or decay, and then by average rate of change from years 1 to 3. So let's just start with initial sales. When you're looking for the initial sales, you're looking at the y-intercept. Especially like if it's a graph, you're really going to look for the y-intercept where it crosses the y-axis. We're given a function though, or we're given a function to model these 2 companies, and so I'm still looking for the y-intercept, but we know that the y-intercept is right here. It's that P in our formula, right? So I'm just going to put company A, f of t equals 250, 1.05 to the t, and company B is f of t equals 175, 0.97 to the t. And so for initial sales, A has an initial sales of 250, and company B has initial sales of 175. And so company A has $75 more than company B to begin with. Okay. right, so now let's look at comparing these companies by their growth or decay rate. Okay, so I'm looking at company A, and our R is going to tell us our growth or decay rate if the number is added to 1, then it's growth. So that means that if your base is bigger than 1, if it's subtracted from 1, then it's decay. So if your base is smaller than 1, you'll know it's decay. So looking at our company A, our base is 1.05, and the rate itself is what's being added to 1. So what's being added to 1 is 0.05. So for company A, our rate is 0.05 or 5%, and it's growing. For company B, we notice that that number is less than 1, so we know it's decaying. And it's decaying, so to figure out how much it's decaying by or what the rate is, you're going to look at how much is being subtracted from 1. So we're not going to put that it's a decay rate of 0.97. We're going to put how much was actually taken from 1 to get 0.97. So we're going to do 1 minus 0.97, which is 0.03 or 3%. And so company A obviously has the higher rate because A, it's growing, and B is decaying, but also even if B was growing, 0.05 is bigger, but it's not, it's decaying. Okay, so then it says we're also going to compare by the average rate of change from years 1 to 3. So I'm going to actually go to the next page to just save some room. Okay, so we're looking at the average rate of change from years 1 to 3. And we're going to look at company A and company B separately. And so to find our average rate of change, we're using y2 minus y1 over x2 minus x1. And remember that your years are your x values. So this is your x1 and this is your x2. And so we're going to need to find our y1 and y2 to be able to plug into the formula. So I'm just going to keep track here. So 1 is my x value for that point, and 3 is my x value for that point. And so to find my y value, I'm just going to take my x value and plug it right into the formula for, I say x, but they're using a t. So for t, and when I plugged in a 1, so I did 1.05 to the first power, and then I took that and I multiplied it to 250, and I got 262.5. And then I'm going to do the same thing with 3. So I'm going to take 3 and I'm going to plug it into my exponent. So 1.05 to the third power, and then I'm going to multiply it to 250. And I got 289.41. And so now that I have my 2 points, now I can plug it into my rate of change formula. So 289.41 minus 262.5 over 3 minus 1. Just make sure you're being consistent. So if you start with this as your y value, then start with this as your x value. If you did it the opposite way, then just make sure you're being consistent, and whatever y you start with, you're starting with that same x value. All right, and so then I'm just going to plug these numbers into my calculator. And so 289.41 minus 262.5 0.5. I get 26.91 over 3 minus 1 is 2. And then I'm going to use my calculator to divide. So I get 13.46 roughly. So company A is growing at an average rate of $13.46 from years 1 to year 3. I'm going to do the same thing with company B. So for company B, I'm using the same X values, and I'm going to plug those in to get my Y values. So now I'm plugging them into that function. So I'm doing 0.97 to the first power, which is just 0.97, and then times 175, and I get 169.75. And I'm going to do the same thing with 3, so 0.97 to the third power, and then multiply that to 175, and I get 159.72 roughly. And now I'm going to plug into this same average rate of change formula. So 159.72 minus 169.75 over 3 minus 1. Plug that into my calculator. So 159.72 minus 169.75. I get negative 10.03 divided by 2, which is approximately negative 5.02. So the average rate of change from years 1 to 3 for company B is negative $5.02. Okay, so for this next problem, it says Julian, the video game designer, has 2 options for the leveling point system in an upcoming game. His options are f of x and g of x displayed below. The variable x represents the level the player is on. So I'm just going to kind of write that so I can remember. So x is the level of the player. And I'm looking specifically for option 1 or option 2. This option is modeled with an equation or a function. It's still exponential though, you can tell because the variable is in the exponent. And then this one is modeled by a graph. And it's still exponential. You can see that nice exponential curve to it. They both look like they're growing. And so let's look at how we can compare. So let's just start with comparing the y-intercepts or the initial values. Okay. And so for this one, so for f of x, our initial value is our p, which is 20. And for g of x, we can find our initial value by looking at the y-intercept, which is 15. So of the 2 point systems, option 1 starts off with the highest point, or highest amount of points. Okay, so let's look at their growth rates. So it looks like for option 1, so for f of x, our growth rate, we know it's bigger than 1, so it's being added to 1, and so 0.10 is what's being added to 1, and so our growth rate is 10%. So it looks like every level, the points grow by 10% of the previous level. And so then for option 2, we're going to have to do a little bit more work to figure that out. So to figure that out, I'm going to use or I'm going to figure out what my growth rate is just for the 2 points that I know, so from 0 to 1. Well, I can see that from 0 to 1, g of x grew 3 points because it went from 15 points to 18 points. To figure out the growth rate, I'm going to see how much 3 points compares to my initial amount of points that I started with. So 3 over 15. And that should give me my growth rate. So when I divide 3 by 15, I get 0.2. So that means that g of x is growing by 20%. So it looks like for option 1, we're starting out higher. In points, but then it isn't growing quite as fast. So g of x starts lower, f of x starts higher, but then f of x grows slower and g of x grows faster. So for Julian, it's really going to depend on what he wants. Does he want a point system that starts out higher, or does he want a point system that's going to grow faster? Okay, so let's look at transformations of exponential functions. And you should have covered transformations with some functions already in your classes. You might have seen it with quadratics. You might have seen it with absolute value, but this is what it looks like with exponential functions. And so I have 2 functions, and I just use generic letters, but my first function is f of x, and my second function is g of x. And so you'll notice that the only differences between f of x and g of x are for g of x, I have this minus h here, and this plus k. And so I want to talk for a minute about what those do to your graph. So for k, you'll notice that the number, k will be a number. It's either going to be added to or subtracted from the end of your function, and so it won't be in the exponent like the h. It'll be like added to or subtracted from the end. And so if k is a positive number, then your function is moving up k units. And if it's a negative k, then let me actually write this differently because I don't like the way that I'm wording that. So if k is positive, then it's moving up, and if k is negative, then it's moving down k units. Okay. The one that gets a little bit confusing is h, and so h is going to move your function left or right. And so in your function, you'll notice that h is in the exponent with x, and so what I like to tell my kids so that it helps them remember is that x's lie to you. That's why they're your x's. So if it's like x minus h, then that would make you think that it's moving to the left, but it's not. It's actually moving to the right. So that's what I mean by x's lie to you. That's why they're your x's. So if it's like x minus 2 or x minus 3, then it's moving to the right that many units. So to the right h units. If it's x plus something, then it's moving to the left however many, so left h units. Okay. And so it does get a little bit tricky because it's the opposite of what you would think that it is. All right, so this next example, it says Julian is working on a complicated game system that raises the difficulty of the enemies in a game. Julian is using the function, so there's our function to model the difficulty level. here's our graph. What effect would there be if the function was modified in the following ways? So we're going to start with A, which is f of x plus 15. So just like in my exponential model, if I added 15 to the end, I was moving it up. And so it's the same concept here. So 15 is added to the end of the function. And so this would be moving your graph up 15 units. For B, we have f of x minus 3. Notice that our number is grouped with x, so x's lie to you, that's why they're your x's. So you might think that because you see this minus here, it's moving to the left, but this is actually moving to the right. So remember, x's lie to you. So this is moving right 3 units. So if it's grouped with x, it's moving left or right, and it lies to you. If it's not grouped with x, if it's added to or subtracted from the outside, then it's moving up or down, and in this case, it's exactly what it looks like, so A is moving up. For our next one, so first we have f of x minus 23, so here again, I have something being subtracted from the end of our function, so this is moving it up or down, and in this case, it's moving down because it's negative, so down 23. Now this last one we didn't touch on, but it's okay, we can talk about it. So for D, they want to know what f of negative x would be. So making something negative, what it does is it reflects your function or flips. If you, and it's also kind of the opposite of what you would think, so this one is making the x negative, so this one is going to reflect the y-axis. If you were to make the y negative, so if it was negative f of x, or your whole function, just every sign turned negative or turned the opposite of what it was, then that would be reflecting the x-axis. So this one, because just the x is getting is becoming negative, then it's reflecting the y-axis. All right, so for this next question, it says compare the functions based, I'm talking faster because I'm running out of time. Compare the functions based on the parameters in each question and make your own observations before revealing the answers. 4 companies show their sales as functions f of x below. And so which company has the highest sales value? And so let's just go, or highest initial sales. So we'll go through and look at all of our p-values. And so the company with the highest would be C. Which companies are decaying? So remember, decaying is when your base is a number less than 1. So it looks like growing, growing, decaying, growing. So company C is decaying, and which company had the largest growth rate? So we're looking for the largest decimal place, which would be A, because it's growing by 20% or 0.20. Okay, in our last example, it says the number of ticket holders arriving at a concert are represented by the function. So here's f of x, where x is measured in hours. The staff for the concert hall is modeled by the function g of x. What does the function show the total number of people at the concert? So our ticket holders is going to be f of x, and our staff is going to be g of x. So f of x plus g of x added together should be our total staff members. So f of x was 250 times 1.3 to the x, and our g of x, I got that from right here, our g of x was 35. So this is our new function for all of our people at the concert. And then how does the graph of that function compare to f of x? Well, remember that f of x was this. This is our f of x plus g of x, and so the only difference is that plus 35 on the end. And plus 35 on the end, we know moves our function up 35 units, and we are done. So I hope this helps, guys. Bye.